Hello everyone, this is Ashani from Cheenta.com. Today we will be solving a beautiful combinatorics problem from ISI-BStat BMath entrance. However, this problem is also useful for Mathematical Olympiads such as IOQM, American Math Competition, and so on. So the problem is actually quite simple if you really apply your mind to it. I'll explain the problem. It says that there are 12 numbers 1 to 12 and n1, n2 up to n12 is a permutation or a rearrangement of these 12 numbers. So just take the 12 numbers, jumble them up and rearrange them. But this rearrangement has a very specific property. The property is this. We want such rearrangements where n1 is greater than n2 is greater than n3 is greater than n4 is greater than n5 is greater than n6. So that happens. So this thing happens. n1 greater than n2 greater than n3 greater than n4 greater than n5 greater than n6. And we have n6 is less than n7 is less than n8 is less than n9 is less than n10 is less than n11 is less than n12. So all the permutations with these properties. Okay. Now, if you look into these two inequalities, they have to be simultaneously satisfied. And one thing that immediately comes up is that n6 is the smallest of all the numbers, isn't it? Because n6 is smaller than these, the ones that come after it. n6 is smaller than these, the ones that come before it. So n6 is clearly the smallest number in this particular permutation, and therefore n6 is equal to 1. The smallest number is 1, right? So that's sorted. Now what do we have to do? Well, we have to find out these numbers and these numbers. So we have 11 numbers remaining. We have 11 numbers remaining because we have already picked up n6, which is 1. That's a fixed number. So from these 11 numbers, we have to have this permutation. Now let's see how we can do that. Let's randomly choose 11 numbers or 5 numbers out of 11 numbers. So maybe I choose 2, 7, 5, 10, and 4. I chose 5 numbers from 11 numbers. Okay. What I'm going to do is I will just write them in a descending order. So 10 greater than 7 greater than 5 greater than 4 greater than 2. I just wrote them in a descending order. Now we already know the 6th number is 1. Notice that I can just simply rearrange them in descending orders. These 5 selected numbers, I can rearrange them in descending order. And that clearly is a possible first 5 numbers in the rearrangement. And the remaining numbers that I have, I can just arrange them in the ascending order. And that will give me the entire sequence. So what are the remaining numbers? Well, 1 is used, 2 is used. So 3 is remaining, 4 is used, 5 is used, 6 is remaining, 7 is used, 8 is remaining, 9 is remaining, 10 is used, 11 is remaining, and 12 is remaining. So these are the numbers, and I'll just put them in an ascending order, which I have already done. So this is one permutation. So 10, 7, 5, 4, 2, 1, 3, 6, 8, 9, 11, 12. That's one example of the rearrangement of the 12 numbers which satisfies our property. You see what I just did? I just fixed the number 1 in the middle, which my conditions imposes. And then I just randomly picked 5 numbers. And as soon as I did it, I got a unique rearrangement. As soon as I picked 5 numbers, I got a unique rearrangement that satisfies my conditions. So, let me write that. Every time I pick 5 numbers, I get a rearrangement, a permutation, a unique permutation, which satisfies my conditions. Right? I get a unique permutation which satisfies my conditions every time I pick 5 numbers. This is a very important principle. It's called the bijection principle. There is a bijection between choice of 5 numbers out of 11 numbers. This set, there are several ways of doing that. The set of choices of 5 numbers out of 11 numbers and the set of rearrangements, set of permutations which satisfies the conditions given in the problem. There is a bijection between them. There is a one-on-one onto mapping between these two sets. Every time I choose 5 numbers, I get a rearrangement that satisfies my conditions in the problem. And every time I have the conditions in the a rearrangement that satisfies a condition in the problem, it's basically corresponding to a choice of 5 numbers from the 11 numbers. It's a very powerful principle, bijection principle. We discuss it a lot in our Math Olympiad program, in the ISI-CMI Entrance program. So the answer simply is 11 choose 5. Because every time I choose 5 numbers out of 11 numbers, I get a permutation of my desired properties. That's the final answer. I hope you liked the problem and you learned something from it. If you are interested in outstanding mathematical programs, physics programs, computer science programs, check the link in the description and I think you will like it. Take care. I'll see you in the next one. Bye.